Okay, let's see how you guys did. We were supposed to express this relation as a table and as a graph, and then state the domain and range. Well, as far as the table, we have to separate, so we have negative 3, comma 1, so that would be negative 3, 1, 2, negative 5, 0, negative 4, and 5, 0. Alright, now let's make a graph. So if we plot the point negative 3, 1, that means 3 to the left because the negative 3, and then up 1. And then 2, negative 5 means 2 to the right and down 5 because of the negative 5. 0, 4 means don't go left or right at all because of the 0, and then go down 4 because of the negative 4. And then 5, 0, that tells us to go 5 to the right and then nothing up or down. So that would be right here. Okay, so your graph should look something like this. Now the domain is all the x values. These first values are sometimes called input values. Okay, these y values are sometimes called output. So the domain is the set of all the input values. So we'll just put negative 3, 2, 0, and 5. The range is all the y values, all the output values. So that will be 1, negative 5, negative 4, and 0. Okay, the domain is easy to read off the table, and so is the range. So far, so good. What else do we have? Now, next objective, which ordered pairs are solutions to the equation? Please understand that this is not multiple choice. There can be more than one right answer. More than one answer. Okay, so you need to sort of check them all. So say if I want to check the point 4, 11. I'm going to substitute the x and y into this equation and see if it makes sense. So putting the 4 in for x, and putting the 11 in for y, this equation becomes negative 3 times 4 plus 11. And the question is, does that equal 1? Well, negative 3 times 4 is negative 12. So we have negative 12 plus 11. Does that equal 1? Well, no it doesn't, because negative 12 plus 11 is equal to negative 1. Alright, and negative 1 does not equal positive 1. So that is not a solution. Okay, but let's try 1, 4. If I do 1, 4, it's going to be like this. I feel like changing colors. So now I've got negative 3 times 1 plus 4. And we're still saying, does that equal 1 or not? Well, negative 3 times 1 is just negative 3. Negative 3 plus 4 does equal 1. So yes, that is a solution. So that's a yes. This one was a no. Okay, let's check the next one. using this point right here with the negative 2, negative 5, that would be negative 3 times negative 2 plus negative 5. And the question is, does that equal 1? Because this equation ours has the 1 right there. Negative times negative is a positive, so that'll be a positive 6 plus negative 5. 6 plus negative 5, that's the same thing as 6 minus 5, and that is 1. Okay, so that's another yes. So that's a solution. Yes. Okay, one more. Let's go purple. So now I'm going to use this one. So negative 3 times negative 1, because that's my x value, plus negative 2, because that's my y value. And again, we're checking, does that equal 1? Negative times negative is a positive, so that's 3 plus negative 2. That's the same thing as 3 minus 2, so that does equal 1. So that is yet a third yes. Okay, so all three of these points are solutions, but the first one was not. Same deal for number 3. So let's just try these one at a time. Okay, so say if I do 2 and 1, then I've got 9 equals 5 times 2 minus 1. Let's see, does that make a true statement? Well, that's 9 equals 10 minus 1. 9 equals 9. So yes, that one worked out. Okay, let's draw a line and try the next one. 1 and negative 4. So does 9 equal 5 times 1 minus, now be careful, this says minus y, but y is a negative number, so that'll be minus negative 4. It's like a double negative, one negative from the subtraction and then another negative because it's a negative 4. Don't forget that there are two of them, so this will become 5 times 1 is just 5. But minus a negative, when you subtract a negative number, it becomes addition. So 5 minus negative 4 is the same thing as 5 plus 4. And of course 5 plus 4 is 9. So yes, that also is a solution. Okay, so that's 2 in a row. Let's try this next one. Does 9 equal 5 times x, so that'll be negative 2, minus y. Okay, here comes that double negative again. Minus y. Y is a negative number, so that'll be minus negative 1. So be careful. Do you remember what happened? So this will be 9 equals. 5 times negative 2 is negative 10. Minus a negative is addition, so this will be like negative 10 plus 1. Negative 10 plus 1 is negative 9. So those are not equal. 9 and negative 9, so that is a no. Why? In fact, let me not even circle it. Instead of circling it, I'm just going to put a big X through it. No. Alright, one more. Let's do purple for 411. So does 9 equal 5 times 4 minus 11? 5 times 4 is 20. Minus 11 is 9. So that is another yes. Okay, so once again we have 3 points that are solutions and 1 that was not a solution. So that's how you tell if a point is a solution to an equation or not. If you plug it in, it doesn't make a true statement. Okay, so we're supposed to graph the equation y equals 4. I've taught you how to do this before. There's two things I want you to keep in mind. I really want you to memorize that y equals a number is always going to be a horizontal line. Okay? Y equals 4. A way of thinking about that is, because y equals 4, all of the y values have to be 4. Like 4, 4, 4, 4. That's what it means for y to be equal to 4. All of the y values have to be equal to 4. So for example, we might have negative 1, 4, 0, 4, 2, 4, 3, 4. If I plotted these points, that would be like this: negative 1, 4, 0, 4, 2, 4, 3, 4. And you can see that is forming a horizontal line. Okay, that's another way of remembering how to graph these. Just pick a few points that have a y value of 4. Similarly, I would like you to memorize that if you have x equals a number, it's always going to be a vertical line. And again, a way of thinking about that is, if x equals negative 2, that means the x values are always negative 2, like this. So you could make up whatever y values you want, like 4, 2, 0, negative 1. I just made up random y values. You could pick whatever y values you want. But then if I plot those 4 points, it should show me what this line is going to look like. Negative 2, 4, negative 2, 2, negative 2, 0, and negative 2, negative 1. I've plotted these 4 points, and you can see it is forming a vertical line as predicted. Okay? So that's a new way of reminding you how these equations work and how to graph them. Okay, and here are just some notes reminding you of what I just said. Vertical lines always have equations like x equals 1, x equals 2, x equals 3, and so on. Horizontal lines always have equations like y equals 1, y equals 2, y equals 3. So, with that in mind, if you're going to write the equation of a vertical line through 2, 5, well, we're talking about a vertical line. Okay? Remember that vertical lines have equations that are always x equals something. So if it's going to be a vertical line, you know it's going to be x equals something. It's just a matter of x equals what? Well, look at the one point that we have here. Which one of these are the x value? The 2. Okay, so the equation must be x equals 2. Or let's take a look at it on a graph. We're supposed to write the equation of a vertical line through the point 2, 5. Okay, so let's take a look. The point 2, 5 would be right here. So there's the point 2, 5. And we want a vertical line through that point. Okay, so this would be a vertical line. Alright, I'm not very good at that, so I better cheat. Alright, we want a vertical line through that point. Okay, so we have a vertical line at 2. So if you guys remember that vertical line is always x equals something, then it's a vertical line at 2. So you know it's going to be x equals 2, which makes sense because x is 2 for that particular point. So x must be 2 for all the points. Okay. Look at number 7. Write the equation of a horizontal line through the point 3, -1. A horizontal line. Well, we just talked about that. If it's horizontal, they're going to have equations that are y equals something. So you know this is going to be y equals something. Which one of these is the y value? -1 is the y value. So you know it's going to be the equation y equals -1. Again, looking at this on a graph, 3, -1, horizontal line. Okay. Oh, okay, these are all positive numbers. Alright, so here's the point 3, -1, and we're supposed to have a horizontal line through 3, -1. So of course a horizontal line is going to look like this. And if you remember that a horizontal line is always y equals a number, then it's a horizontal line at -1. So it should be obvious that this is the line y equals -1, which again makes sense because that is the y value. So that's kind of the shortcut. Okay, let's look at number 8 and 9. Find the range of each function if the domain is -3, 2, and 5. Well, you know, we're basically talking about making a table of values. Okay, we're talking about this. So the domain is like the x values, and the range is the y value. So if the domain is -3, 2, and 5, so here's -3, 2, and 5, then the range will be the y values that we get if we plug these in. So for example, y is -3 times x, so this would be -3 times -3. This one will be -3 times 2, and this one will be -3 times 5. Alright, y is -3 times x. So if we do that, -3 times -3, that's going to be 9. That's going to be -6. And this is going to be -15. So there you go. So that's the we're supposed to find the range. This is the range right here. So the range is just 9, -6, and -15. Okay, same thing for this one. Just making a table of values, domain and range. So we're told that the domain is -3, and 2, and 5. Alright, so the range, well, y is 2 times the x value plus 1. So this would be 2 times -3 plus 1. And this will be 2 times 2 plus 1. And this will be 2 times 5 plus 1. Okay, well that's going to be -6 plus 1, and that's -5. This will be 4 plus 1, which is +5. And this will be 10 plus 1, which is 11. Okay, so the range for number 9 is just going to be -5 and 5 and 11. Okay. Number 10 and 11 are almost the same thing, but we're given the range and we're supposed to find the domain. Okay, so this is the deal. We're still thinking in terms of domain and range, like x's and y's. Okay, so this will be my domain, this will be my range. We're given that the range is -4, -2, and 1. So we have -4, -2, and 1. We need to find the x values that go with these y values, basically. So for example, let's start with -4. If we put in -4 for y, then that means -4 is equal to x plus 5. If we subtract 5 from both sides, that will give us the x value. So that's going to give us x equals -9. Okay, so that means the domain value is -9. Now let's do the next one. If the y value is -2, that means -2 is equal to x plus 5. Again, let's subtract 5 from both sides. And that's going to give me x equals -7. Okay, so that gives us another domain value. Let's do that one more time for a y value of 1. So that would be 1 equals x plus 5. Again, let's subtract 5 from both sides. So that's going to give us x equals -4. Okay, so you can see that these are the domain values right here. Okay, so the domain for number 10 was -9, -7, and -4. Okay. I feel like I should mention to you, since see how this equation is already in the form y equals x plus 5, it might have been a little bit quicker to use the calculator if you're allowed to do it. So have out your TI-30XS multi-view if it's not too inconvenient. Just have that on your desk real fast. Y equals x plus 5. So remember, your calculator has a table button on it. So press that table. It says y equals, so we could just type in x plus 5. If we hit enter a few times, okay, until we get the table going. Now, so we wanted, we were given range values like -4, -2, and 1. Okay, so I can kind of scroll around. Look at these range values. Okay, there's a range value of 1. Look, the domain value is -4. See, 1, -4. Then we have -2 coming up. Okay, so just scroll. See, there's -2. Boom, -7. Okay, which is exactly what we have. And then -4. But we could just scroll to a range value of -4. And oh look, -9. And that's what we had. So if you have y by itself, you can use a calculator to find the values. Okay, keep that in mind. Okay, look at problem number 11. We're supposed to do the same thing. Okay, let me just make a line right here. Okay, so I'll make my table over here. Domain and range. You know what I mean? These are the x's, these are the y's. Again, we're given the range. So we're given the -4, we're given the -2, and we're given the 1. And so we're supposed to plug that in for y and see what x is. So let's start with -4. So if I do 3 times -4 equals 2x, see what's going to happen. So that's going to be -12 is equal to 2x. If I divide by 2 on both sides, that's going to give me x equals -6. I feel like I should have showed that. Yeah, so like I was saying, if I divide both sides by 2, like that, then that's going to give me x equals -6. So if the range value was -4, I'm getting a domain value of -6. Okay, let's do that again with -2. Okay, so this would be 3 times -2 is equal to 2x. If I divide by 2, no, not yet. So that'll be -6 equals 2x. Now if I divide by 2, like so, that's going to give me -3. It's going to give me x equals -3. So I've got that value. Okay, I'm going to have to squeeze this in down here. Hope I don't need this space for anything else. So if I do, I'm going to do this final value of 1. So that'll be 3 times 1 is equal to 2x. Well, that's just 3 is equal to 2x. If I divide both sides by 2, like this, look, that just gives me x equals 3 over 2, or 1.5. Okay, so for right now, I'm just going to put 3 over 2. As a decimal, it would have been 1.5. Either way, I could say that the domain, okay, my domain is -6, -3, and 3 over 2, or 1.5. Okay, so that was the answer for number 11. Okay, what is left? Classify each of the equations below as linear or nonlinear. Explain. Okay, well basically the things, things that are linear are could be written as in the form y equals mx plus b. Okay, if they're linear, they could be written in this form. So things to watch out for: if you have x times y, that's not linear. If you have an exponent on your variable, like x squared or x to the third power, that's not linear. Or if you have a variable in the denominator, okay, like something over x, that is not linear. So watch out for those things. So looking at number 12, I don't see xy, I don't see an exponent, nothing's in the denominator. This is linear. Okay, I mentioned being able to write it as y equals mx plus b. I could have easily written this as y equals 3x plus 0. Okay, that would be the same thing. So that is linear. Looking at number 13, is this linear or not linear? This is not linear because of the xy. Okay, if there's xy in there, it's not linear. Alright, what do you think about number 14? Say linear or not linear. Y'all didn't say anything, did you? Speak up. Answer these questions. This is linear. It's linear, okay? There's no xy, there's nothing squared or to the third power, there's no variables in the denominator. This is linear. If I added 2x to both sides and divided by 4, I could rewrite this as y equals mx plus b. What about number 15? Linear or not linear? That is linear. You know, if you have x equals a number or y equals a number, that's a vertical line or a horizontal line. All right, if it makes a straight line, that's linear. X equals a number is always a vertical line. Okay, so that's definitely linear. What about number 16? Linear or not linear? It's definitely not linear because of the xy. Okay, you can't have that. What about number 17? Linear or not linear? That one is linear. Okay, there's no xy, there's nothing squared or to the third power, there's nothing in the denominator. If I subtracted x from both sides and divided by 3, I could write it as y equals mx plus b. What about number 18? Linear or not linear? This one is not linear because of the x in the denominator. Okay, it's this third rule. You can't have a variable in the denominator, so that's not linear. What about number 19? Linear or not linear? That one is linear. Okay, that's a yes. If I divided both sides by 5, I could write this as y equals 1/5 x plus 0, no problem. That is linear. What about number 20? Is this linear or not linear? Not linear because of the x squared. If you have a variable squared or to the third power, that is not linear. Okay, if you were to graph this, you would find that it would form a parabola. Okay, and we will add to that another day.